For OSI, the physical layer regulates some transmission media, network interface and specifications. For example, on the internet, I pass 010101. It's like I'm actually sending an electrical signal. In the future, what your device receives is obviously an electrical signal. How can I convert it into data? First of all, this network port should put this 0101. To convert it, I want to convert the high and low battery to 0101. Then compile it on the computer. Transfer and convey and read upwards. So it is a whole set of complete process. Then all standards pertaining to the upper layer of our physical communication hardware are defined by the physical layer. It is equivalent to the standard that regulates our overall transmission medium. Device-to-device interconnection. How about the network cable? What does it look like? How to make a crystal head? In what line order? These standards must be formulated. This is what the physical layer does. There are many transmission media in the physical layer, such as cable and fiber. In the future, everyone will know if they learn wireless. We can also propagation based on air as the transmission medium. So we physical layer. The whole has the existence of a transmission medium. The transmission medium can both realize the interconnection between devices data transmission. This is what the physical layer can do. But it also has some disadvantages. For example, let me give a simple example. I am now this PC. I want to remotely access the server of company C. You see I'm in area A. Right? I am going to access this C company server in B region. I'm going to upload a piece of data now. I passed an electrical signal. High and low battery. Anyway, I go through the network. Send to this device. But we now think about a problem. If the PC sends data again in the future, if I connect to wireless, maybe my intermediate data is not stable. Or I pass the network cable. There may be some strong electrical equipment in the middle of the data. Link is unstable. Or there may be some interference. Because after all we're sending electrical signals. We have a most basic word called electromagnetic induction. Although some students do not know how to operate. But everyone needs to know. For such an electrical signal, it is very susceptible to strong electrical interference. For example, if you pass some strong power supply in the middle, passing by some high-power appliances, then you may be disturbed. Because we say the signal passed, called high and low battery. You may be passing a high voltage. Then suddenly the low voltage. What does this amount to? Equipment room. Let's say we're actually passing the code for 0101. However, due to the possible instability of the intermediate circuit, you pass 0. Suddenly it was passed to you as 1. Then your entire data transfer is wrong now. Then I now have a data. I want to send from this PC1 in area A to company C. If my data just went out, just arrived on this switch of our company, my data has been disturbed. Already wrong. I don't need to pass this data to the destination. First, the forwarding resources of the operator equipment along the route must be occupied. That same moment, if the intermediate data is subject to some delay, suffered some damage, that's been destroyed right from the source. It doesn't make sense to pass it on. When the C company data is parsed, it's definitely not the same as the original analysis. It's like you sometimes download some files online. Maybe due to unstable network in the middle. Sometimes the files get corrupted after unzipping. Among them, you may be missing 1 or 2 data. may result in corruption of your entire data. Then you will actually find that it is not optimized. It is also equivalent to the data in my middle ran so far, but after reaching the destination, but could not be successfully parsed. Then in fact your one network communication already interrupted. So we'll find out now. If your data itself is wrong, then there is no need to reach the destination. Then here comes the problem. As a network device, how can I know that there is a problem with the data in transit? We need a behavior mechanism now. Everyone will find the physical layer can, of course, solve the interconnection between devices and pass data. But if we make mistakes in the data, cannot be detected. Let's take a look at the data link layer. Is it possible to achieve such a function? For example, now one of my data sent from my PC to the middle switch. For switches, the switches we usually come into contact with in NA. It is a very standard layer 2 device. We should not detect 3-layer features at the NA stage. It is a layer 2 device. That's for layer 2 devices. In fact it is working in the data link layer we just talked about. Then in the data link layer, we will have a function called error detection. That is, the data will be sent in the future. We will run this data once. Integrity check. We will mention today what kind of a mechanism to perform this check. Once the data is, the whole is sent to the middle switch. The switch will be on layer 2 to check the integrity of this data. So if for our data, by checking I think this data is complete. This is just one of the parameters. If this parameter passes validation, at least this data can be. Then send it to you. If it does not pass the verification here, that proves that your intermediate data is physically damaged. Then the data will be lost directly. Remember this. That is, for our data link layer, it has a very important role. It is possible to complete an error detection. Second, it has another function. On our overall data link layer, there will be a very iconic parameter called MAC address. What's the use of this address? I give an example. For example, there is a data in the future sent from outside. I sent a data to company C. Company C gave me back the package. The packet that company C sent back to me was sent from the router. How do I know this data is sent to PC1? Or PC2? Or PC3? As a switch, it has a communication standard for data forwarding. It is called viewing the MAC address of the peer for data forwarding. That is, in the future we can be on the second floor, have a MAC address as an in-range location function on a small link. Every one of our PCs, there will be a different MAC address in the future. Then a data will be sent in the future. If you are going to access the MAC of PC1, I can accurately locate your current PC1, equivalent to our MAC address on the second floor. It is to provide us with address information on a link. This is called a MAC address. It is the function of realizing precise positioning. For now, we have two functions on the second floor. The first one can implement error detection. Secondly, the standard precise positioning function can be realized. But it has another problem. We all know the devices on the link. That is to say, it is now within a range. These devices connected through a switch. We can locate by MAC address. Please pay attention. We generally refer to switches. Everyone has to think of the MAC address. Routers mentioned in the future. You have to think of IP addresses. IP address, and we'll talk about it later. For us, what do they actually represent? A router represents a layer 3 device. Then, in 3 layers, we have an important parameter called IP. A switch represents a layer 2 device. On the second layer, which is the data link layer, we have an important parameter called the MAC address. So you need to put these 2 parameters and 2 devices working on different levels to match. That is, for a device on the link, it cannot cross this link. That's what we just said. Is a data to the network connected to the switch. The switch can be judged. Information about the MAC addresses that are now connected to these terminals. But once you get rid of the whole switch now, as long as you go through a router's interface, MAC addresses are relatively useless. That is, the MAC address is to work within our scope. I'll be more straightforward. In the future, if you this PC, I want to find the server of company C in region B. You can't find it by relying on the MAC address. That is to say, the MAC address cannot access a remote device. It can only access the device in front of it and connect it through the switch within a network. Such an address, it can be found. Broadly speaking, it cannot provide address identification. Then now, there is no way for us to complete the corresponding functions on the second floor. We're going to look up for the second floor. One of the first functions it can perform. We can find bugs, implement an error detection. If there is a problem with this data, I lost this data, but I can't go any further. What is the next step? For example, I now send a message to the peer. Then my message is damaged in the middle. But for the sender device, this data has been sent. Some device lost the data in the middle. Then this device needs to notify me. This data is not passed to the destination, but for the second floor. It can only be responsible for throwing this data away. It has no way to notify the original device. So this is a function that the second layer cannot complete. This is the first one. The second one is like what I just told you. There is no way for a MAC address from our macro, or to analyze the address information from a global perspective. That is, its scope of action is relatively narrow, precise but too small. What kind of address do we use for identification? We are on the third floor. There will also be a parameter on the network layer. It will also carry an address information. IP address. So for IP addresses, the scope in which it takes effect, not on a link. It does not take effect within the scope of such a link. Rather, in the process of passing all data as a whole, it will take effect. But for our MAC address, our data throughout the transfer process, MAC addresses are subject to change. For example, you are now from region A. Send a courier to area B. For example, you are in the first middle school in area A. It is the second middle school in the province of B region. So, for example, there is a man named Tom. Another person's name is Mary. Tom from the first middle school, Mary from the second middle school. This is actually the equivalent of an IP address. Throughout our express logistics delivery process, your recipients and senders never change. But for the middle, for example, if you come from area A, then you arrive at transfer station number 1. Then pass through transfer station number 2 and transfer station number 3. Then you end up in region B. Then in it, you will go through a lot of different links. Then on each link, your MAC address will be changed. Just like which transfer station you arrive at in your logistics information. Each stage of this information has a source and a purpose. Equivalent to you going from transfer station 1 to transfer station 2. You are now sending a small message. It is also equivalent to reporting your data every time you also has a source and a purpose. This is equivalent to the concept of a small scope transfer, like a MAC. On each link, we will all have a source MAC and a destination MAC. But for our entire data transfer process, we will only have one source IP and one destination IP. Is equivalent to the effective range of the MAC address is relatively small, but the scope of our IP address is valid during the entire transfer. Its address information will not change. It's on our whole one data location, because we will learn the corresponding configuration later. But for the earliest, even if people don't fully understand their scope, but first you have to be clear. Can't distinguish IP from MAC. You need to know what they do. Otherwise it will be difficult to learn. Let me stress again. During a data transfer, MAC address it may change frequently, but the IP address is definitely fixed. This is what we call an IP address. It's a coordinated plan. This is the first concept of our 3 layers. IP address. There is a second concept in the second 3 layers. Routing. Routing means simple. I'll give you an example. Just now I sent a data from here. How can this data finally reach the C company server? This thing is called routing. That is an address for our destination in the future. I was able to query this data. We have a concept called routing table. Query routing table for data forwarding can ensure that the final data, original destination, that is to say, the data is sent. If there is no concept of routing, I actually don't know how to go this route. We will learn a table. Routing table. We query according to the routing table. And forwarded. We can do it. The future arrives on every device in the middle. Note that these are the operator's equipment in the middle. We only need to go through the equipment to check the table. Then locate the next device. Our entire internet transmission. It's a form called a baton. One device to another device. There are several transits along the way. And finally reach the destination. We call it a baton transfer form. Then the baton is to rely on routing. Relays that come and go. Or complete data forwarding. This is a concept we will learn in the future. We will also talk about a basic concept of routing today. It is also a network segment problem. So for IP and MAC, don't think that these 2 parameters are separated. For example, I'm going to communicate. Can only have IP or only MAC. This is not possible. In the future, we will truly deliver effective business data. Both addresses are definitely needed. We will learn a message in the NA phase. Then there is a packet called ARP. In the future, everyone will be exposed to some data. You will find that this data may not have 3 layers. That is, there is no such IP address. But we call data like this. Do not call our future business data. Business data is the future that really carries your business traffic. For example, if you visit Company C on your computer, this data is called business data for Company C. For such data, the top layer of your data is the application layer. Has real data content. Then for such data, either MAC address or IP address. Must have. It's just that we'll learn some protocols in the future. In part of the agreement you will find. It seems that some protocols seem to only have MAC. No IP. It doesn't mean that the 2 of them can be one less. When we will learn later. Let me explain to you. Let's summarize the network layer. What the network layer can achieve. First, provide an IP address. To locate a device's location globally, we can achieve forwarding. Locate a device. Next is routing. This is the function of our 3 layers. But we still have 3 layers of functions that cannot be achieved. We can clearly see. What about 3 layers? The first feature we can't implement is called error correction. Our second floor. For example, sent a data. If this data is wrong, it was lost by the switch. Equivalent to at the data link layer. An error detection was made and lost the data. But there is no way for the third floor. Corrected for this data. Correction is to tell the original device that the data has not been sent, need to post again. We call this correction. The 3-layer network layer can't do it. The second is that the network layer still has no way to implement another function for one of our devices. If I'm opening multiple apps, it is impossible to distinguish. For example, now I take this PC3 as an example. I have 2 applications open at the same time on PC3. One is WeChat. One is WhatsApp. Suppose I have a unique IP address. Not to mention any other conversions today. Suppose I now have some corresponding servers on the right. On the far left is the WeChat server. In the middle this is WhatsApp. When I make data access in the future, let's restore the process of accessing. Suppose my WeChat wants to access the WeChat server. And now my WhatsApp goes to access to WhatsApp server. I can communicate. I have to get on board and connect to the server. My chat history and account password are kept inside. I have to log into this server first. So now we have a problem. For our 3-layer network layer, provide something called an IP address. Then it can uniquely locate the location of our PC. So for WeChat and WhatsApp, they're going to give me back. My WeChat reply package is to this PC. Because now the IP address of this PC sent me. My WhatsApp package is also returned to this PC. Then for our network layer. Now there are 2 servers at the same time. I gave you 2 pieces of data. Do you know which data is WeChat? Which data is WhatsApp? This creates a new problem. That is, now only if there is only one IP address. Then all future business you visit can communicate with you. When your data is passed, the server addresses of WeChat and WhatsApp are different. You can find both of them. But when they return to you, you only have one IP address. Ask them for the data. How to distinguish your device. Next we look at the transport layer. In the OSI reference model. That is, the network layer now has only one IP address and a routing function. We don't have any other features. We have the concept of a port. The transport layer can provide a new parameter or a new variable. Port. For example, I am currently local. Give WeChat a parameter called X. Give this WhatsApp a parameter called Y. In the future, when I have a communication visit, I will take my local IP address plus now this port to communicate with WeChat. Then in the future, when WeChat replies to me with data, it puts the data back on my X. If I want to communicate with WhatsApp on my local PC in the future, I'll take Y to communicate with it. Then the future WhatsApp server, when replying to me with data, it takes this data. Reply to this Y on my local is equivalent to. Now although we only have one IP address, but we can build on this. Initiates or expands the concept of a port. We will talk about this later. But it won't go into too much detail. Just as everyone understands. Equivalent to our present. Developed a new variable. On that port. We can have different port IDs later. First of all, you need to know. Every time I want to access a process locally on the device. Actually, I will have a corresponding port. Is a randomly initiated port. A random port greater than 1024. Then this port is recorded locally. Then I will carry this port when communicating. My local generated port. Communicate with the outside world. Of course. The peer you access also has a port. Communication between our data and data. Each layer must be parameter equivalent. But for WeChat and WhatsApp, their ports are also fixed. For example, if you go to visit the web service of Company C, you are actually accessing the 80 HCP of Company C or 43 HCPS such ports. It will reply to the corresponding port in the future. For the same device, I receive different data on different ports. If the port number is X, give it to WeChat. If it is Y, give it to WhatsApp. Some students will talk about UDP and TCP. Our two transport layer protocols. One is TCP. One is UDP. This is one of our transport controls. A user packet. We will also mention briefly to mention both of them later. But today I will give you a general introduction. That is, what function can it achieve? This is one of. Then there is another. What we just talked about is, for the data link layer, we can perform an error detection at the switch. As a switch, it is a data link layer product. Implement error detection. If once it fails the test, I lost my bag. So how do I correct it? We will have two protocols at the transport layer. Just like a classmate said a while ago called TCP. One called UDP. If the future transport layer, we choose the TCP protocol, then it can be retransmitted. Once our transport layer uses TCP for encapsulation in the future, halfway through your data transfer, the data is lost. We are able to base on this agreement. Data retransmission. But not if it is UDP. Data is lost. You just have an impression. Because for the fourth layer, it should go to IE and then go to contact. And we can't learn many functions of the fourth floor. This is the function of our 4 layers. Next, let's take a look at the 3 layers above. But we as engineers now, what we focus on is actually the 2nd, 3rd, and 4th floors. More precisely, in fact, we focus more on the 2nd and 3rd floors. First you need to know, as the upper 3 layers dot. Actually it's more developed. That's what some developers do. Some corresponding processing. For our web workers, we are more concerned about the network communication. That is, the network can't get through. As long as we go down to the 4th floor, we can do it well. This network communication is no problem. As for the future between your applications, how to verify, including between your apps. Specifically, what means carry out some corresponding control. So how to compile, how to decode, how to do some compatibility. This is what the application layer needs to do. That's what developers do. But let's briefly talk about the first 3 layers. But I won't be too specific. We just mentioned a concept. Local. We have a port number. An identity. Come and go to differentiate between different apps on my device. But we actually have a new problem. Between some different applications, we have to distinguish one thing. Process. Did you know this stuff? For us now, we open a page of the Google server. Let's say I'm searching for a word now. You will find that there are many corresponding options below. That is, I am now searching for it through the web. Then please pay attention. It's different, like some options are actually different subprocesses. That is actually for them. You are accessing the server of Google, but you are accessing a different process in the Google server. So it is equivalent to, although you are also accessing the server of Google now, but actually for your device. In fact, your current device, different processes are started. They are all Google. That's for the port number. The port of our transport layer. It can only be based on our service, or positioning based on application. So what exactly is this service? It can't be done. How do you do it? Let's move on to the session layer. The session layer can realize our different application processes. That is, the distinction between service processes and service processes. It's enough for you to understand. For the process. In fact, it is also a process. But it's a subservice in the process. There are still some differences. That is, strictly speaking, a process that everyone understands. In fact, in our broad sense, a concept of service. But for the process, it also differentiates between subservices in a process, or subprocess. Then for it, our transport layer can't do it. Need to use session layer. Looking further up, there is a layer called the presentation layer. The presentation layer is responsible for compiling and decoding data. For example, suppose I'm on the left and this is a PC. Then this PC assumes that the installed system is a Windows system. Under Windows, we can actually implement software-to-software communication. First, you need to know both PCs are Windows system, able to communicate with each other. Everybody knows. Now the server is actually based on Linux system. We're going to knock orders with Cisco's equipment in the future. Actually, we are using Cisco iOS system. It is also a secondary modification based on Linux. So in fact, 4 different systems. They all have differences between the underlying systems. Like me now. I downloaded a Windows system on the PC side of my device. Installed a WhatsApp. For example, the PC here. I'm on a desktop version of Linux. Also installed a WhatsApp. So even for the same software as WhatsApp, but it's actually a different underlying operating system. That is for us. Even if our underlying architecture is different. But in fact, everyone knows it doesn't affect our communication with each other. Then here comes the problem. Data encoding format under our Windows. That is, the encoding format of WhatsApp. It is different from the Linux system. Then if the encoding form, under different circumstances, data looks different. How did you communicate? That is, how do you connect future data? There will be a session layer among us. It will be dedicated to compiling and decoding our data. Then put our different underlying systems under all data. Convert to a standard format. Communicate based on the middle. It's like people going to translate the language of a country. Become a universal language. We all translate into a standard language. Communication is the same. Let's just understand. That is, we can implement between different operating systems in different underlying environments. It will not affect the data of the upper application software. I can convert the representation to a generic standard encoding format. This is our 6th floor. The last one is our 7-layer application layer. The application layer actually implements relatively many functions. Let's start with the first function. The application layer is the first to bear the brunt of the problem to be solved. It's the problem that the lower models can't solve. I just mentioned to you. I say if the future is at the transport layer. We use a protocol like UDP. In fact, it has no way to complete the data retransmission. If a data fails the data link layer check. Then if the 4 layers choose TCP, it is capable of retransmission. If it is UDP, it cannot be retransmitted. For example, we are now a WeChat chat box. I am sending data to others now. If at some point my internet is not very good, then there will be a red exclamation mark in front of the message. After we artificially click on this exclamation mark, data will be resent. That is to say, for our data, if I am within the stipulated time, I didn't send this data. It is equivalent to my sending failed. I don't automatically send. That is to say, these agreements we are now following, or the lower level, it can't solve this problem. Then only by means of this application. Develop an exclamation mark here. Such a button. Make you click this button artificially. As long as you automatically resend the data for you. This is equivalent to a retransmission of the data. That is, your data is in the process of transmission. Due to network problems, there was a problem with the data transfer. But this data will not be in the situation that the network gets better again. Automatically deliver for you. We cannot retransmit. We all retransmit manually. Then, for the lower level, if you are chatting on WeChat now, the protocol we choose now is UDP. Automatic retransmission is not possible. Application layer. Develop some tools. That is, some means of access. Help you achieve retransmission. Is to rely on manual resending. This is called an error correction process. At the application software level. If for you during the video, network stuck for a while, it can't be passed. Because for video, this timely flow. If you lose it, lose it. No need to retransmit. So different business flows. There will be some different standards in the future. So does this thing need to be retransmitted? Are defined by the software. Like WeChat thinks you are sending data. Or some voice messages sent. Is capable of retransmission. Then they provide the corresponding button. If you are making a voice call. If several packets are lost in it. Network stuck a few times. They see no need for retransmission. They won't give you corresponding retransmission measures. Then you lose this data and lose it completely. This is our reference model for OSI. In addition to this function, the application layer, and others. For example, different data can be generated. Are different programs in the future. Or between different applications. Our data are all different. I sent a message on WhatsApp. What I generate is based on the data generated by the WhatsApp application. WhatsApp it will conform to some of the specifications of an application like WhatsApp. That is, the specifications made by some applications. Between the different applications, specifications are different. Based on our current application layer, can generate different data. And one last point. It's our authentication or encryption method. Actually, for authentication and encryption, we prefer to refer to the large application layer. Actually, for a function like this. In fact, we still follow the overall TCP/IP standard. What we call the function implemented by the large application layer. For example, account password. All are based on the verification methods set by our large application layer. then provide you with an identity verification in the future. Here's what we're talking about. Last encryption. Speaking of which, let's make a summary. We are now a 7-tier architecture. In the 7 layers. Each layer is able to implement the problems of each layer. In other words, it can solve the problem of each layer. The physical layer solves the transmission medium pair. The physical layer connects devices. Transmit our data signals. Then the data link layer. We have 2 more important parameters. A MAC address. Another is to provide the function of error detection. For the network layer, there is a core parameter called IP address. Secondly, there is a function called routing. There are 2 major protocols at the transport layer. One is TCP and the other is UDP. We have another protocol station called TCP/IP. In fact, it is the TCP protocol used at the transport layer. And network layer IP protocol. IP protocol is called Internet Protocol. And our transport layer, what we call the TCP protocol. 2 major protocols make up such a name. This is our transmission control protocol. What we are using now. In fact, it is the protocol station of IPv4. That is for us now. These 2 agreements are very large. Represents the core of our entire data communication learning. The 2 most powerful agreements. Everyone is relatively familiar with the IP protocol. Everyone is unfamiliar with TCP. The overall development cycle of the TCP protocol is about 20 years. It can achieve a lot of functions in it. The overall development cycle and design cycle are very long. Actually, we as networkers. In fact, only about half of the knowledge in TCP can be accessed. The remaining half is for programmers to touch. So such an agreement. Don't ask everyone to fully grasp. Even if you get to IE, you can't learn all the functions of TCP as a whole. So what we are more important is to revolve around us on the 2nd and 3rd floors. To discuss our overall web technology. Of course, the transport layer is also very important. But relatively speaking, there are not as many as the 2nd and 3rd floors. Based on the 7 layers of our current OSI reference model. Each layer it can solve the problem of each layer. So the final question. The development cycle of a program is relatively long. Then each layer, it has to choose a specified protocol. Then in theory our application is developed as a whole. If you now go up layer by layer to the application layer, there is one more problem that has not been solved. So basically this app or this service don't go online because it is inherently problematic. In theory, as long as it reaches the application layer, everything in your app, it should have been resolved. Also known as the bug of this software. So sometimes you will find some software needs to be updated all the time. Been going to fix some bugs before. There are some problems during development. Routers and switches are really in terms of devices. There is no essential difference. The difference between them is, from my current point of view, they work differently. For the switches we are talking about now, it can be understood as our layer 2 switch. It works on our data link layer. That is, for a layer 2 switch, it can only process information that sees at most our data link layer. A data to a switch. This packet can only be split to the 2nd layer at most. The contents of the 3rd floor cannot be seen. That is, in this data, all the IPs it offers, including some addressing forwarding. The protocol used by the 4-layer delivery layer. I don't see any of these. I only look at the content in the data link layer. Data forwarding based on IP address. For layer 3, the router receives the data. After the second floor, I will see the third floor. In layer 3, I will check the source IP and destination IP, and query the routing table for forwarding. Switches and routers. At this stage we are. First, the levels of the packets they view are different. It works on the second floor. It works on 3 layers. It sees that packets are split to layer 2. It sees the packets are split into 3 layers. It is based on the MAC address table. Perform data forwarding on the chain. It provides data forwarding throughout network communication based on routing. Because query routing, it's another level. It's not the same concept as our second floor. So just tell everyone. There is no essential difference between a switch and a router.